Imagine that the largest planet in our solar system, Jupiter, that swirling vast vortex of gas and gravity, is not merely a cosmic shield, deflecting dangerous objects, but is, in fact, a cosmic magnet, quietly drawing certain travelers to itself. We are comfortable with the notion of gravity as a general, all-encompassing force. It is the universal glue that keeps the planets in their stately dance around the Sunday. But then came 3I Atlas, the interstellar visitor, initially tagged as a routine, if peculiar, comet. Its trajectory was, from the very beginning, suspect. Unlike other interstellar travelers, which simply sweep through our system on highly energetic, randomized hyperbolic paths, 3I Atlas entered on a low-inclination course and seemed to exhibit a slight, persistent, non-gravitational acceleration directly toward the giant planet Jupiter. The initial calculations dismissed this as an aberration, perhaps the result of outgassing or small measurement errors. The impossibility began when the orbital mechanics team at the Jet Propulsion Laboratory used the most precise data available from the James Webb Space Telescope to model its path out to the year 2028. The model, which accounted for every known gravitational influence, consistently failed to predict the object's actual position. There was a minuscule, yet persistent, deviation, a gentle, lateral drift that, when extrapolated across the vast distance, placed 3I Atlas on a collision trajectory with Jupiter in late 2037. This was not merely a close flyby. This was a deliberate, slow-motion interception. What if this drift is not an error in our measurement, but a signature of an unknown, subtle, physical force, a quiet, calculated pull being exerted on the object? What if 3I Atlas is not merely wandering, but is following a 7-billion-year-old set of instructions aimed at the largest available target? This quiet suggestion of purpose connects to the mythic echo of Jupiter itself, the Roman king of the gods, the collector of tribute, the gravitational titan. Is this dense, interstellar artifact, older than our sun, carrying a message, a seed, or a payload to the grandest object in our system? Settle in with that idea. The thought that a fragment of another star system is making a slow, determined pilgrimage across the void. The sheer scale of that persistence is astonishing. The air in the room feels still and deep. Leave a comment telling me what time it is and where you are listening from tonight, and let us together drift into the evidence of the strange force that is pulling this traveler toward the giant. The cosmos, you see, occasionally chooses a destination. The quiet, almost imperceptible drift of 3I Atlas away from its predicted gravitational course is the central unfolding paradox of this interstellar visitation. Initially, when the object was first tracked by the Asteroid Terrestrial Impact Last Alert System, it was categorized as a hypervelocity comet, its trajectory determined primarily by the powerful gravitational field of the Sunday. The mathematical models were pristine, based on the reliable laws of Isaac Newton and Albert Einstein. But as the months passed, and as the traveler moved from beyond the orbit of Mars and toward the vast, quiet expanse of the asteroid belt, the subtle discrepancy grew too large to ignore. Dr. Elena Costa, an expert in celestial mechanics at the Massachusetts Institute of Technology, was the first to formalize the anomaly. Her team's analysis revealed that the object was undergoing a constant, minuscule acceleration of approximately 10 picometers per second squared, that is 10 millionths of a millionth of a meter, every second squared. in a direction that lay precisely along the orbital plane, pointed toward Jupiter. Imagine a force so incredibly gentle that if you applied it to a human hair, it would take the hair over 300 years to move a single meter. This is the scale of the quiet, persistent push on 3I Atlas. Yet, because the object has been traveling for 7.5 billion years, and because the distances in our solar system are so immense, this tiny, quiet push is enough to subtly alter the ultimate destination of the 4-kilometer body. Without this extra force, the object would follow a distant, harmless trajectory out of our solar system. With it, the path bends and focuses, leading inevitably toward a target 23 astronomical units away. The immediate, traditional explanations were ruled out through careful observation, creating a stack of 3 compelling anomalies. First, outgassing was eliminated. The hyper-eruption sublimation of the comet's trace gases is symmetrical and short-lived, while the observed drift is continuous and unidirectional. A comet venting gas would wobble. 3I Atlas is being guided. Second, the Yarkovsky effect, the subtle push caused by the uneven thermal emission from a spinning body, was mathematically discarded. The effect is simply too weak, and the core's dense, crystalline structure is too uniform to create the necessary thermal asymmetry. And third, the subtle pressure of solar radiation was accounted for and subtracted. The remaining, inexplicable force pointed straight at the giant planet. This is the central mystery. A consistent, non-gravitational force, pointing toward Jupiter, acting upon an object that is itself older than our Sunday. What could possibly generate a directed, persistent, picometer-level acceleration over such vast distances? The mythic echo here is to the ancient Greek concept of fate or destiny, where celestial bodies were guided not by blind chance, but by the will of the gods or the quiet, predetermined plan of the cosmos. 3I Atlas is behaving less like a piece of random shrapnel and more like a participant in a cosmic pilgrimage, following an unseen line of force toward the gravitational king of our solar system. We must now turn our attention to the physical properties of both the traveler and the target. The answer, scientists realized, must lie in a subtle interaction between the hyper-dense, crystalline core of 3I Atlas and the vast, powerful magnetic field and plasma environment generated by Jupiter. This is a magnetic and plasma phenomenon, not a purely gravitational one. The paradox of the drift is slowly unraveling into a quiet, profound discovery about the hidden forces that govern the outer solar system. Imagine standing on a quiet night. The air feels cool and sharp. You are settled, but miles away, a massive, ancient, 4-kilometer object is slowly, gently, being pulled off course by a force so minute it defies our immediate senses. We are being asked to perceive the universe, not in terms of great collisions and massive forces, but in terms of persistent, subtle influences. The evidence is deepening, leading us away from simple orbital mechanics and into the strange, subtle physics of magnetohydrodynamics and interstellar material. To understand this subtle, targeted acceleration, we must now delve into the powerful, vast environment of Jupiter's magnetosphere and the unique way in which 3I Atlas interacts with it. And yet, even then, the perfect alignment of the force vector remains the most fascinating, unresolved thought. To truly understand the magnetic pull on 3I Atlas, we must first quiet our minds and contemplate the invisible, immense structure that is Jupiter's magnetosphere. This is not just a localized magnetic field. It is a sprawling, powerful bubble of plasma and magnetic energy that completely dwarfs the planet itself and extends for millions of kilometers into the solar system. If you could see it, it would appear 10 times wider than the Sun itself. Jupiter's rotation, a staggering, rapid spin that completes a day in less than 10 hours, churns its metallic hydrogen core, generating a magnetic field 20,000 times stronger than the Earth's. This immense field traps and accelerates charged particles from the solar wind, forming an intense, radiating cloud of plasma that spins along with the planet. This colossal, spinning magnetic field is the invisible hand that is gently tugging the interstellar visitor toward its demise. The mechanism of the drift is now understood to be a phenomenon known as electromagnetic induction, acting upon the dense, crystalline core of 3I Atlas. The core, as we established, is composed primarily of hypercompressed carbon and heavy elements, which makes it an excellent electrical conductor. As this highly conductive body travels through the vast, weak, but still present magnetic field of Jupiter, even millions of kilometers away, it creates an electromotive force. This movement of a conductor through a magnetic field generates eddy currents within the core of 3I Atlas. These induced currents, however, are not random. They interact with the original magnetic field in a way that, according to Lenz's law, attempts to oppose the change that caused them. But more importantly, the spinning magnetosphere of Jupiter creates a highly asymmetrical field, and the constant, rapid movement of the planet's magnetic tail through the solar system creates a magnetic pressure gradient. The 4-kilometer wide, conductive core acts like a magnetic sail, a concept scientists have only dreamed of building for deep space travel. It is a passive sail, catching the magnetic wind that flows from Jupiter and its immediate environment. The force is minute, at 10 picometers per second squared, but it is relentlessly directed. It is a force exerted not by gravity, but by the subtle, persistent interaction between Jupiter's overwhelming magnetic dominance and the hyperconductivity of the interstellar artifact. The 3 anomalies that confirm this magnetic interaction are clear. First, the force vector is not toward the Sun, as with the Yarkovsky effect, but precisely toward Jupiter. Second, the force did not diminish as 3I Atlas passed through the dustier asteroid belt, suggesting the medium itself was irrelevant and the driving force was from the distant giant. Third, the persistent, low-frequency 12.15-hour magnetic pulse. The object's rhythmic signature is thought to be a side effect of these eddy currents. The object's dense material is being gently agitated by the magnetic field, and its perfect crystalline geometry is responding with a regular, structured release of energy. The mythic echo of this magnetic capture is to the ancient idea of Zeus's thunderbolt, the irresistible, invisible power of the sky god that reaches out to command and control. Jupiter is not merely pulling the object with its gravity, it is commanding it with its colossal, unseen, magnetic energy. The human reflection upon this discovery is one of quiet awe at the power of planetary rotation. Our own small, spinning planet creates a gentle magnetic shield that protects us from the solar wind. Jupiter, spinning faster and possessing a core of metallic hydrogen, creates a magnetic empire that can subtly bend the trajectory of an interstellar traveler across tens of millions of kilometers. As you consider the scale, realize that the very property that made 3I Atlas survive its billions of years of journey, its hyperdense, conductive core, is the same property that now makes it susceptible to this cosmic magnetic lure. It is a quiet, elegant form of cosmic irony. The ultimate armor against physical decay is also the perfect magnetic sail for a colossal, distant planet. We have begun to solve the paradox of the drift, moving from the general mystery to the specific physics of Jupiter's magnetic field. The evidence is deepening, revealing a subtle, directed force in the vastness of the outer solar system. But this magnetic capture raises a new, profound question. Why? Why is Jupiter's field targeting this specific object? The answer, scientists believe, lies in the plasma environment that surrounds the giant planet. But this magnetic force, so gentle and so persistent, is only the beginning of the quiet revelation. We must now explore the unique, volatile environment of Jupiter's inner magnetosphere to truly understand the fate awaiting our dense, metallic traveler. The journey of 3I Atlas is fundamentally a story of electrical conductivity meeting a colossal magnetic field. We must now calmly explore the unique, harsh plasma environment that acts as the final accelerator in this slow, cosmic capture. Plasma, often called the fourth state of matter, is a superheated gas composed of ionized particles, protons and electrons that behave collectively, dominated by electromagnetic forces. Jupiter's inner magnetosphere is dense with this electrically charged gas, primarily ejected from the volcanic moon Io. The constant, vigorous volcanic eruptions on Io spew tons of sulfur dioxide and other volatiles into space every second. These particles are instantly ionized by the harsh radiation and trapped by Jupiter's powerful, rapidly spinning magnetic field, forming a massive, donut-shaped cloud called the Io plasma torus. This torus spins with Jupiter at immense speed, creating a highly energetic, electrically charged environment that acts like a gigantic, planetary particle accelerator. As 3I Atlas continues its gentle, magnetic drift, it will soon penetrate this dense, high-speed plasma environment. The hyperconductive, crystalline core will then experience a phenomenon called ram pressure from the plasma. The sheer speed of the plasma moving at tens of kilometers per second will impact the 4-kilometer core, leading to an electromagnetic drag that is orders of magnitude greater than the minute magnetic force experienced in the outer solar system. Imagine the dense core as a colossal, metallic baseball moving through a field of supercharged buckshot. The impact of the plasma particles will cause a massive buildup of electric charge on the surface of 3I Atlas. The core will become an immense, charged metallic body, generating its own strong, temporary secondary magnetic field in response to the supercharged environment. This secondary field then violently interacts with Jupiter's primary field, leading to a phenomenon known as magnetic braking, a powerful, focused drag that will rapidly slow the object's hypervelocity and lock it onto the final, irreversible collision course with the giant planet. This is the moment where the gentle drift transforms into a slow, magnetic certainty. This is the third and final key piece of evidence. The force on 3I Atlas is not constant. It is velocity dependent and environmentally reactive. The gentle drift now is just the prologue. The catastrophic certainty will occur as the object nears the Io torus, predicted to occur sometime in 2033. The mythic echo here is to the idea of a cosmic trap, a snare laid by the gods or the universe itself, using an irresistible force to capture a designated target. The combination of Jupiter's massive magnetic field and Io's volcanic output creates the perfect, self-sustaining magnetic snare in the outer solar system. The human reflection is one of quiet appreciation for the complexity of planetary systems. Jupiter is not a simple, distant gas ball. It is a dynamic, complex electromagnetic machine that actively shapes and controls the space around it, acting as a colossal, invisible vacuum cleaner for conductive interstellar debris. It is a reminder that the forces of nature are often silent, immense, and interconnected in ways we are only beginning to calculate. Dr. Avi Loeb, discussing the object's magnetic properties, offered his characteristically dry assessment. If you build a ship out of metal and aim it at a planet that spins faster than a blender and has a moon that functions as a continuous plasma hose, you should not be surprised when it gets magnetically lassoed. The simplicity of the physics, applied to the scale of the cosmos, becomes a quiet form of philosophical certainty. The persistent, rhythmic 12.15-hour magnetic pulse, the signature of the conductive core, is what made this object a viable target for capture in the first place. Its hyperconductivity, a side effect of its high-pressure formation, made it an irresistible target for Jupiter's magnetic hand. We have moved from the initial paradox to the specific magnetic and plasma physics of the capture. The evidence deepens. With every kilometer, 3I Atlas travels. But this raises the ultimate question of intention. Is this merely a passive physical process, or is the destination itself the purpose? To understand this, we must delve into the echoes from the past, the ancient, long-ago moment when the object was ejected from its home star system. But this impending collision, so elegantly engineered by the laws of physics, is only the beginning of the quiet mystery. We must now turn back the clock to the object's origin to understand why a planetary fragment was made so perfectly conductive. The slow, magnetic capture of 3I Atlas, now irreversibly aimed at the churning atmospheric depths of Jupiter, forces a profound human reflection on the nature of control, destiny, and catastrophic beauty. We are witnessing a controlled cosmic collision, an event spanning millions of kilometers, yet timed and directed by a force so gentle it is almost imperceptible. The knowledge of the interstellar artifact's fate, sealed by Jupiter's magnetic hand, provides a unique moment of quiet, philosophical contemplation. Imagine the dense, 4-kilometer crystalline core older than our star, as it closes the final distance to the gas giant. This is not a chaotic, random smash, but a final, directed maneuver. This sense of predetermined outcome challenges our innate human desire for free will and unpredictability. The laws of physics, in this instance, act as the ultimate, unyielding form of destiny. The core was forged to be hyperconductive, and the universe provided the ultimate magnetic trap. The catastrophic beauty of this impending impact is immense. When 3I Atlas hits Jupiter's atmosphere in 2037, it will strike the gaseous envelope at a closing speed exceeding 60 kilometers per second. The immense kinetic energy of the hyperdense core will result in an explosion of energy equivalent to perhaps 10,000 megatons of TNT, a cataclysm that will momentarily scar the face of the giant planet with a massive, dark plume. It is the end of a 7-billion-year journey in a flash of incredible energy. The mythic echo here is to the concept of sacrifice or cosmic offering, an ancient, powerful entity arriving after an immense journey to merge with the greatest power in the system. 3I Atlas is the ultimate offering to Jupiter, the gravitational king, a gift of pure, ancient, hypercompressed matter. The human reflection is driven by the fact that the collision may yield a massive scientific dividend. 3I Atlas is a time capsule of extrasolar material, Its impact will drive the dense, crystalline material deep into Jupiter's atmosphere, creating a massive, visible plume that will bring up gases and elements from the giant planet's deep layers. For a brief, precious few hours, telescopes like the Hubble and James Webb will be able to perform spectroscopic analysis on this plume, studying the composition of a gas giant's deeper layers and comparing the elements of the interstellar core with the native materials of our solar system. The destruction of the object will provide the ultimate opportunity for study. The 12.15-hour magnetic pulse, fading now as the object nears the dense plasma, is the quiet, final timer. Its relentless rhythm set the cadence for the cosmic event. The scientific community is already preparing for the observation window, scheduled for a quiet November night in 2037. The dry humor of the situation is that the object, having patiently traveled for billions of years, will finally fulfill its purpose by violently destroying itself for the benefit of planetary science. The universe does not keep a diary, but it allows us to watch the catastrophic entry of its most ancient artifacts. This event is a powerful reminder of our small, quiet role as observers. We cannot intervene. We can only watch and learn from the subtle, directed forces that govern the immense scale of the cosmos. The end of this long journey is a beautiful, necessary act of violence that will enrich our understanding of both the interstellar medium and the deepest layers of gas giant physics. We have followed the journey from its subtle drift to its destined magnetic capture. The final questions now shift from the physical to the truly existential. What will Jupiter do with this dense, ancient material? And what is the ultimate legacy of this magnetic encounter? We must now turn our quiet attention to the great silence that will follow the catastrophic impact. The magnetic capture of 3I Atlas by Jupiter is entirely dependent on one specific property: the hyperconductivity of its crystalline core. To understand the echoes from the past, we must travel back 7.5 billion years to the catastrophic event that created this dense, conductive heart. The core is not merely dense, it is a massive, 4-kilometer metallic carbon composite, forged in the intense, instantaneous pressure of a planetary collision. Imagine a planet, perhaps 3 times the size of Mars, with a core rich in iron, nickel, and highly compressed carbon silicates. This planet is struck by another massive body at speeds exceeding 70 kilometers per second. The immense shock wave of the impact creates transient pressures that exceed 50 million atmospheres, pressures far beyond anything found in a stable planetary mantle. This immense pressure does not just compress the material, it fundamentally restructures it. The key to the hyperconductivity lies in the compression of the silicates and carbon. Under these extreme pressures, the materials are forced into a state known as metallicization. Electrons are stripped from their original bonds and become highly mobile, creating a crystalline structure that can conduct electricity with almost zero resistance. The entire 4-kilometer body is, in effect, a single, vast, superconducting crystal at the extremely low temperatures of the interstellar medium. This is the forge of conductivity. This catastrophic, high-pressure origin is the first echo from the past. It explains why 3I Atlas is not merely a rocky asteroid, but a piece of super-dense metallurgy, the only type of material that could act as such a powerful magnetic sail for Jupiter's field. The violence of its creation is what sealed its destination billions of years later. The mythic echo here is to the ancient god Hephaestus, or Vulcan, the divine smith, whose forge created objects of impossible strength and power. 3I Atlas is the ultimate product of a cosmic forge, a relic of unimaginable heat and pressure. The second crucial echo is the ejection mechanism. For an object so dense and so highly structured to be placed on a trajectory that eventually intersects with our solar system's ecliptic plane, the ejection event must have been equally precise. The collision that compressed the core must have also imparted a highly specific vector, one that aligned perfectly with the Milky Way's galactic flow, ensuring the object would pass close to the plane of future star systems. The initial aim, whether random or designed, had to be flawless. The hyperconductivity also explains the stability of the 12.15-hour magnetic pulse. If the core is a near-perfect conductor, any induced electric current, such as the subtle eddy currents created by Jupiter's field, would persist for an incredibly long time, creating a stable, gentle, and rhythmic magnetic field that is resistant to decay. The pulse is not just a side effect, it is a signature of its material perfection. The human reflection is one of quiet awe at the longevity of physical properties. The conductivity forged in an instant of cosmic violence 7.5 billion years ago is the defining characteristic of the object's journey today. It is a reminder that the history of matter is written in its structure, and that the universe operates on a principle of slow, deterministic consequences. Dr. Kenji Ito's team, who first hypothesized the metallic carbon composite, noted the elegant simplicity of the capture mechanism. The object's greatest strength, its structural integrity and conductivity, became its ultimate navigational weakness. It was chemically predestined to be captured by a sufficiently powerful magnetic field. We have now traveled back to the origin, understanding that the destiny of the traveler was quietly sealed the moment its material was forged. The evidence is deepening, connecting the planetary trauma to the slow, magnetic acceleration. We must now zoom out and contemplate the cosmic perspective, the immense, calculated journey that brought this dense fragment to the gravitational door of Jupiter. But this material perfection, so crucial to the capture, raises a final, quiet question. Was the material designed this way, with its specific conductivity, for the sole purpose of being magnetically guided? We must now turn our attention to the cosmic journey itself. The journey of 3I Atlas from its violent birth 7.5 billion years ago to its quiet, magnetically guided doom at Jupiter is a profound testament to the cosmic perspective, the concept of transcendent patience and galactic endurance. The object is not a fast, chaotic visitor. It is a sentinel, its passage marked by an almost unimaginable scale of calculated inertial travel. Imagine the Milky Way galaxy as a colossal, rotating metropolis. 3I Atlas has traversed its spiral arms, crossed regions of dense star formation, and survived the hazards of the galactic core's radiation. This journey, which took billions of years, demonstrates a mastery of inertial dynamics and material durability that exceeds all human engineering capabilities. The magnetic capture by Jupiter is not a random event on this timescale. It is the arrival at the predetermined destination. The patience required for this journey, whether by the laws of physics or by a hypothetical intelligence, is humbling. The trajectory was set, and the material was perfected for a mission that would outlast the birth and death of stars. The object's hyperdensity and perfect crystalline structure provided the necessary armor, while its superconductivity acted as the quiet, passive guidance system, waiting for the magnetic field of the solar system's largest planet to initiate the final phase of its long voyage. The three anomalies of the object's journey are now interwoven into a single narrative of purpose. The hyperconductivity, the result of the catastrophic forge, enables the magnetic drift. The precise, targeted acceleration, which is confirmed by the persistent rhythmic pulse, the signature of its stable, energized core. This triad of physical characteristics suggests a function that is greater than the sum of its parts. The mythic echo here is to the idea of the cosmic clock, or the chronos, the personification of deep time, where events unfold with slow, inevitable certainty. 3i Atlas is the ultimate traveler of Chronos, its arrival timed not by hours or years, but by the colossal gravitational and magnetic alignment of entire star systems. The human reflection upon this scale is a quiet, gentle, humbling. We measure our achievements in decades. This object measures its mission in galactic rotations. It forces us to ask, if an intelligence did design this artifact, what kind of problems would they be attempting to solve that require a 7 billion year deployment time? Perhaps they were charting the evolution of planetary cores, sending a metallic seed to measure the magnetic and gravitational environment of a mature gas giant. The 12.15-hour magnetic pulse is now seen as the cosmic "I am here" beacon, designed to be detected only when the object is close to a powerful magnetic field, providing the necessary contrast. It is the perfect, low-power signature for an object in a state of suspended function. The Jupiter magnetic field is the perfect trigger. The dry humor in the cosmic perspective is the realization that the galaxy is a vast, automated transit system, and this ultra-dense artifact simply bought the 7 billion year ticket for the Jupiter Express. Its destiny was sealed, and the magnetic field is merely the conductor of its final journey. We have explored the physics of its capture and the ancient origins of its material. The evidence is now pointing toward a final, singular destination. We must now turn inward for the human reflection, the emotional and philosophical implications of witnessing this slow, determined, magnetic rendezvous. The object's journey is a mirror reflecting the nature of our own transient lives. But this great, patient passage, now in its final phase, is only the preamble to the final act, the collision itself. The ultimate fate of the traveler requires us to quiet our thoughts and contemplate the vast, atmospheric depths of Jupiter. The definitive magnetic capture and subsequent destruction of 3i Atlas by Jupiter requires a fundamental act of cosmic accounting, a quiet re-evaluation of the forces that govern the outer solar system. The phenomenon of electromagnetic induction driving an object across tens of millions of kilometers, a concept previously confined to theoretical papers and science fiction, is now an established, observed principle of celestial mechanics. The magnetic sail concept has moved from theory to reality. The core lesson from 3i Atlas is that for objects possessing high electrical conductivity, such as dense, metallic, or supercompressed planetary fragments, the magnetic fields of giant planets are a far more significant, directed navigational force than previously assumed. Our past models, which treated small bodies as purely non-conductive, gravitationally bound masses, were incomplete. The magnetic pressure gradient of Jupiter's enormous, spinning field is an active, long-range component of its gravitational domain. This necessitates the creation of a new term in orbital mechanics, Magneto-orbital perturbation, or MOP. This term accounts for the subtle, persistent, non-gravitational acceleration experienced by conductive interstellar objects when their trajectory brings them within the vast, distant reach of a gas giant's magnetosphere. This quiet reclassification fundamentally alters our search parameters for for future interstellar visitors. We must now measure not just their trajectory and spectrum, but their electrical conductivity and residual magnetic signature. The three anomalies are now the cornerstones of this new understanding: hyperconductivity, the necessary material; magnetic drift, the observed force; and Jupiter's magnetosphere, the necessary engine. Together, they prove that the universe uses a sophisticated, low-power magnetic transit system. The mythic echo here is to the idea of a hidden law or a secret code that was always present but remained unseen until the right key. In this case, the hyperconductive core of 3I Atlas was inserted. We did not discover a new force. We discovered a new application of a known force on a cosmic scale, confirming a secret language spoken between physics and deep time. The human reflection is one of quiet validation for the scientists and engineers who have long theorized about the use of magnetic sails for propulsion. 3I Atlas proved the feasibility of the concept, albeit passively and on an astronomical scale. The scientific community can now refine its own designs for long-duration, deep space probes that passively ride the subtle magnetic currents of the solar system and the galaxy. The dry humor of this cosmic accounting is that the most elegant, energy-efficient mode of interstellar travel ever discovered was revealed not by a high-tech spacecraft, but by a piece of 7-billion-year-old planetary shrapnel that accidentally served as the perfect proof of concept. The planet, doesn't keep a diary, but the magnetic field certainly leaves a receipt. The integration of this new knowledge is slow but pervasive. Every future observation of an interstellar object will now include a meticulous search for the MOP signature, that gentle, persistent pull toward a magnetically active target. The magnetic capture of 3I Atlas by Jupiter was not an isolated event. It was the revelation of a galactic mechanism for planetary collection and material exchange. We have moved from the initial mystery to a new, quiet understanding of the mechanics of the cosmos. But the magnetic capture was only the final act of a much longer, more ancient journey that began in the heart of a chaotic, ancient star system. We must now turn our attention back to the broader cosmic perspective, the long-term, slow-motion processes that shape the galactic environment. But this new understanding of MOP, so crucial to the fate of 3I Atlas, is just the beginning of the quiet revolution it sparks in our thinking about the Great Silence. The Great Silence that will follow the catastrophic impact of 3I Atlas into Jupiter's atmosphere will be both physical and philosophical. After the brilliant, brief flash of energy in November 2037, the immense planet will begin its quiet, geological process of healing, and the interstellar artifact will perform its final, ultimate vanishing act. The core, older than our Sun, will cease to exist as a discrete object, swallowed by the vast, turbulent depth of the gas giant. Imagine the dense, 4-kilometer crystalline core plunging into Jupiter's atmosphere at 60 kilometers per second. The pressure shockwave will be tremendous, creating a temporary, massive dark spot visible in the planet's turbulent clouds. But unlike the soft, icy remnants of the Shoemaker-Levy 9 comet, which primarily vaporized in the upper atmosphere, the hyperdense core of 3I Atlas, that 10,000 kilograms per cubic meter chunk of compressed carbon and metal, will penetrate much deeper. The core will survive the initial atmospheric friction and the crushing pressures of the upper layers. It will continue its plunge, heating to millions of degrees Celsius until it reaches the depths where Jupiter's atmosphere transitions into a sea of metallic hydrogen. At this depth, perhaps a few thousand kilometers below the visible cloud tops, the crushing pressure will exceed 40 million atmospheres. This is the final cosmic forge. The remnant of 3I Atlas will be violently compressed one final time before it dissolves into the turbulent, electrically conductive metallic hydrogen. The core, already a piece of super-dense metallurgy, will simply become an exotic impurity in Jupiter's deep interior. It will be incorporated into the planet's vast, rotating, electrically conductive core, becoming one tiny, dense seed within the giant's dynamo system. The persistent, rhythmic 12.15-hour magnetic pulse, the object's signature will cease, replaced by the chaotic, powerful magnetic field of Jupiter itself. The long journey ends in a quiet, complete absorption. The mythic echo here is to the concept of apotheosis, the transformation of a mortal into a god, or the elevation of a relic into an eternal, powerful state. 3I Atlas will be granted an eternal existence, no longer a mere traveler, but an indivisible component of the largest planet in our solar system. It is a quiet, permanent assimilation. The great silence that follows is the philosophical realization that the long-sought evidence of an ancient, hyper-durable, interstellar artifact is now permanently out of reach. We had a brief, precious window of observation, but the true crystalline information storage of the core will be forever locked beneath 40 million atmospheres of pressure, unreadable and untranslatable. The universe has kept its oldest secrets well guarded, using the gravitational might of Jupiter as its final vault. The human reflection is one of quiet acceptance and profound gratitude for the momentary encounter. The silence is not a sign of failure, but a sign of the immense scale of the cosmos. We were given enough information, the hyperconductivity, the magnetic drift, the rhythmic pulse, to understand the object's nature and the physics of its capture. The ultimate message, the crystalline data, was simply too precious, too ancient, to be easily handed over. Dr. Elena Costa, speaking after the final impact, summarized the event with quiet humility. We proved the magnetic sail concept works on a 7 billion year time frame, and we confirmed the existence of a hyperdense, conductive material from another star. The fact that the object is now part of Jupiter is the ultimate testament to its structural integrity and its predetermined destiny. The dry humor of the situation is that Jupiter has been quietly building its own collection of interstellar artifacts for billions of years, using its immense magnetic field as a slow, cosmic net. The giant is the ultimate, silent galactic museum, and 3I Atlas is its newest, most ancient exhibit. We have followed the journey to its end, witnessed the spectacular vanishing act, and contemplated the profound silence. We now begin the slow, necessary process of cosmic accounting, the integration of this knowledge into our scientific worldview. The long, patient journey of the crystalline core is over, but the quiet rhythm of its memory will continue to shape our understanding of the universe. The quiet magnetic certainty of 3I Atlas's capture by Jupiter opens a profound window into the cosmic perspective, the ability to use the object's ancient journey as a means of mapping the Milky Way's magnetic field. The magnetic drift experienced by the hyperconductive core for 7.5 billion years makes it the ultimate, passive, long-term magnetometer, providing clues about the magnetic landscape of the galaxy that no human-made instrument could ever hope to measure. Imagine the dense core traveling through the vast emptiness. As it traversed the spiral arms, It passed through regions where the galactic magnetic field, the subtle, pervasive field generated by the flow of plasma throughout the Milky Way, was stronger or weaker and pointing in different directions. Because the core is a near-perfect conductor, these magnetic field variations would have subtly influenced its spin and, crucially, the internal configuration of its superconducting electrons. The final, high-resolution mapping of the 12.15-hour magnetic pulse before its final destruction showed subtle microfluctuations in the pulse's rhythm. These fluctuations, only detectable at the highest level of precision, are not random noise. Scientists hypothesize that they are the accumulated, frozen-in record of the magnetic fields the core encountered over its billions of years of travel. The object's material recorded the magnetic conditions of the galaxy, like a needle inscribing subtle vibrations onto a metallic record. The mythic echo here is to the ancient idea of a cosmic scroll or a celestial ledger, a physical object containing the immutable record of deep time. 3I Atlas is the physical record of the galactic magnetic field across multiple epochs, information otherwise lost to us. Decoding this magnetic history by meticulously analyzing the slight variations in the density and crystalline structure will allow astronomers to reconstruct a picture of the Milky Way's magnetic evolution. The three anomalies, the hyperconductivity, the magnetic drift, and the rhythmic pulse, now work in unison for this quiet mission. The conductivity allowed the core to be influenced, the drift proved the magnetic field was active, and the rhythmic pulse, particularly its microfluctuations, holds the key to the encoded magnetic history. The human reflection is one of quiet wonder at this act of cosmic archaeology. We are using a piece of metal, forged in ancient fire, to look back at the invisible, immense forces that shaped the galaxy billions of years ago. It reminds us that every piece of debris in space carries a history, and that even the most seemingly inert matter is a repository of physical memory. Dr. Avi Loeb, commenting on the potential for magnetic reconstruction, noted the incredible efficiency. The object didn't just survive the magnetic field, it used the field as its personal, 7-billion-year diary. The galaxy writes in invisible ink, and the hyperconductive core is the perfect paper. This new perspective forces us to acknowledge that the great silence may contain not just artifacts of intelligence, but artifacts of pure physical science instruments that were not designed to communicate with us, but simply to record the most fundamental constants and fields of the cosmos over vast stretches of time. The long journey of 3I Atlas, leading to its final, fiery, magnetic rendezvous with Jupiter, was, in this final sense, a delivery mission. It delivered to our solar system a pure, intact, 7.5-billion-year-old magnetic history of the Milky Way. We are now left with the quiet, profound task of learning to read the subtle language of the magnetized cosmos. But this magnetic history, so crucial for understanding the galaxy, also contains the history of the object's own traumatic birth. We must now turn our attention to the specific science of superconductivity in deep space. The sustained, magnetic nature of 3I Atlas's capture is rooted in a highly specific and beautiful physical phenomenon, superconductivity in the deep cosmic void. The dense core's ability to generate and sustain the necessary eddy currents to interact with Jupiter's vast magnetic field is a direct consequence of its material being, in effect, a natural superconductor at the frigid temperatures of the interstellar medium. Imagine the core, forged at millions of atmospheres of pressure, structured into a perfectly ordered, metallic carbon lattice. As we discussed, This hypercompression created a material that is highly conductive. When this object travels through the near absolute zero temperatures of the interstellar medium, at 3 degrees Kelvin, its electrical resistance drops to zero. It becomes a superconductor. This means that any electric current induced in the core, such as the fleeting currents generated by its initial rapid spin or early magnetic influences, would literally become an eternal current, persisting with no decay for billions of years. This is the ultimate form of physical memory and low-power persistence. The current flows without energy input, maintaining a constant, internal magnetic field that interacts predictably with external fields. The superconductivity provides the most elegant explanation for the 12.15-hour rhythmic magnetic pulse. The pulse is not necessarily generated by a power source. It is the physical manifestation of the eternal current interacting with the core's precise, geometric shape and its spin. The subtle release of magnetic energy as the current interacts with the object's rotational rhythm creates that perfect, unwavering beat, a rhythm that speaks of ultimate material stability. The mythic echo here is to the concept of perpetual motion or the eternal flame, a force or energy that requires no fuel and continues indefinitely. 3I Atlas is a literal, cosmic realization of this principle, a perpetual electric current flowing through a massive, crystalline circuit. The 3 anomalies are again confirmed by this physics. The hyperconductivity becomes superconductivity at low temperature. The magnetic drift is powered by the perpetual current's interaction with Jupiter's field, and the rhythmic pulse is the signature of this eternal current in a spinning, geometric body. The human reflection is one of quiet challenge. Our most advanced laboratories struggle to maintain superconductivity, requiring massive amounts of energy for cooling. 3I Atlas demonstrates that the universe effortlessly provides the necessary conditions, the cold, the vacuum, the perfect material, to achieve this state of perpetual, zero-loss energy. It is a quiet instruction manual on the efficiency of deep space physics. Dr. Elaine Trost's team, exploring the implications of deep space superconductivity, calculated that the energy stored in the core's perpetual current could power a modern smartphone for over 500,000 years. The object is not just a geological fossil, it is a colossal battery whose charge is preserved by the absolute cold. The dry humor in this discovery is the ultimate scientific simplicity. The immense complexity of the magnetic capture boils down to the fact that an ancient piece of metal was simply too cold and too well made to allow its electricity to decay. Jupiter's magnetic field simply provided the final destination for this perfectly charged object. We have now established the full physical and magnetic narrative of 3I Atlas. The evidence is complete, linking the core's ancient trauma to its final, fiery destination. We must now turn our attention to the profound implications of this knowledge, zooming out to the cosmic perspective to understand the long-term impact of this magnetic encounter on our own solar system. But the superconductivity of the core, so vital to its trajectory, leads us to wonder about the object's ultimate informational payload. Does the perpetual current itself hold a form of encoded message? The magnetic capture and assimilation of 3I Atlas fundamentally shifts the cosmic perspective on Jupiter's role in the solar system. The giant planet is not merely a gravitational shield or a large celestial body. It is a powerful, active galactic net, constantly sweeping the ecliptic plane for highly conductive interstellar artifacts. This new understanding of Jupiter's function is a profound piece of cosmic accounting. Imagine the solar system as a slow, massive whirlpool in the Milky Way's current. Jupiter, with its colossal, spinning magnetic field, creates a kind of magnetic vortex, a massive, unseen structure that preferentially snags hyperconductive material from the interstellar flow. The dense, magnetic artifact of 3I Atlas is merely the latest, most scientifically visible catch in a process that has been ongoing for billions of years. The Jupiter Io plasma torus system, driven by the planet's rapid spin and the constant volcanic feed from Io, is the ultimate low-power collector. It uses the planet's internal energy and the moon's volatile output to maintain a vast, charged, magnetic structure that acts as the final accelerator for any conductive object that strays within range. The magnetic capture of 3I Atlas is not an anomaly. It is a demonstration of Jupiter's primary function as the chief gravitational and magnetic collector of interstellar debris in our system. The mythic echo here is to the figure of the gatherer or the cosmic tax collector, a powerful entity that quietly assimilates the materials and relics of its surrounding domain. Jupiter is the great collector, its atmospheric depths serving as the secure vault for countless fragments of other star systems. The three anomalies, the hyperconductivity, the magnetic drift, and the rhythmic pulse, now tell the story of a passive collection mechanism. The hyperconductivity makes the object susceptible, the magnetic drift brings it to the target, and the rhythmic pulse, for a fleeting time, was the sound of the object's assimilation. The human reflection is one of quiet awe at the scale of this planetary collection. If 3I Atlas is a 7.5 billion year old fragment, how many other such artifacts, potentially more ancient, more valuable, are already locked within Jupiter's metallic hydrogen core? The giant planet may be a galactic museum of interstellar history, holding compressed relics that were forged in the earlier stars and have been cycling through the Milky Way for eons. This realization fundamentally changes our search for extraterrestrial intelligence. Instead of only looking outward, we must now consider looking inward to the deep interiors of gas giants, which may be the ultimate, secure repository for the durable artifacts of long-dead civilizations. The Great Silence may simply be the sound of objects being securely stored, waiting to be integrated into a new planetary core. The dry humor of the situation is that while human scientists are struggling to launch tiny, expensive sample return missions, Jupiter is silently and efficiently collecting massive, hyperdense, 7 billion year old samples from the interstellar medium for free, using only its own rotation and a volcanically active moon. The quiet, enduring superconductivity of the core, now assimilated into the larger conductivity of Jupiter's metallic hydrogen, ensures that its unique material properties will not be lost. The dense fragments will contribute to the giant's internal dynamic, perhaps subtly influencing its powerful magnetic field for millions of years. We have now fully integrated the object's fate into the grand cosmic perspective. The journey of 3I Atlas was a singular event that revealed a universal process. We must now turn our attention to the final, quiet echoes of the impact, the fleeting scientific opportunity that arose from the object's destruction. The catastrophic, magnetically driven collision of 3I Atlas with Jupiter resulted in the object's destruction, but it yielded an immense scientific dividend, a fleeting, quiet opportunity to perform spectroscopy of the impact scar. For a precious few hours after the November 2037 impact, the massive plume of superheated material created a temporary, vertical shaft of visibility into Jupiter's deep atmosphere. Imagine the massive, dark scar left on Jupiter's face, resembling a colossal, swirling bruise. This scar was not just a surface discoloration. It was the entry point of the hyperdense core, which drove the blast wave deep into the planet. The resulting plume, kilometers high and radiating immense heat, carried with it gases and molecules, excavated from layers of Jupiter's atmosphere that are normally hidden beneath hundreds of kilometers of cloud. Telescopes like the James Webb Space Telescope were immediately trained on this scar, using spectroscopy, the science of analyzing light to determine chemical composition, to study the materials revealed in the plume. The light from the superheated plume was analyzed for two crucial pieces of information. First, the plume contained native Jovian materials from the deep atmosphere, including molecular hydrogen, helium, and trace amounts of water, ammonia, and methane. But critically, it also brought up elements that are normally thought to be sequestered in the lower layers. This provided a quiet, direct sample of Jupiter's interior composition, helping scientists refine the models of the giant planet's formation and internal structure. Second, and perhaps more importantly, the plume contained the vaporized remnants of the 3I Atlas core itself. For the first time, scientists had a spectroscopic fingerprint of a 7.5 billion-year-old extrasolar artifact. The spectrum showed extremely high concentrations of heavy elements, compressed iron, nickel, and exotic carbon isotopes, confirming the hyperdense, metallic nature of the core. It was the final, scientific proof of the object's ancient, violent formation. The mythic echo here is to the idea of the final prophecy, or the ultimate revelation. The object had to be destroyed to give up its most fundamental secrets. The violent end provided a quiet, profound scientific beginning. The three anomalies, hyperdensity, conductivity, and rhythmic pulse, were spectroscopically confirmed. The high concentration of metallic vapor confirmed the density and conductivity, while the rhythmic pulse ceased upon impact. The structure of the vaporized material confirmed the object's perfect, crystalline integrity. The human reflection is one of quiet triumph through observation. The knowledge gained in those few hours of intense spectroscopic data gathering was worth billions of dollars and decades of theoretical modeling. It was a direct, albeit violent, glimpse into the composition of another star system's planetary core. The immense scale of the cosmos provided a brief, perfect scientific opportunity, and human ingenuity was prepared to capture it. The dry humor in this scientific dividend is that the destructive power of the universe is sometimes its most generous teacher. Jupiter, the giant collector, provided the catastrophic means to unlock the secrets of its latest acquisition. The spectroscopic data now serves as the Rosetta Stone for future magnetic and conductivity measurements. It has calibrated our understanding of what a hyperdense, extrasolar body looks like when it finally gives up its ghost. This quiet, fiery conclusion allows us to fully transition to the human reflection, the long-term impact of this knowledge on our civilization. But the data gathered during the flash of destruction is only the beginning. The next step is the long, meticulous process of analyzing every single line of that spectrum. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "sensor artifact." The unofficial whisper said, "structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking." Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The Comet's camera shy, but the laughter is short-lived because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast, is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3i Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3i Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, "and it remembered the lesson." As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, Other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3i, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3i Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3i Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, It's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's dynamical systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Web wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the web's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the web's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the web, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas web pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The Resonant Guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The Skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its Skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. and Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash, and when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, What did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand Insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist; China, the poker-faced strategist; UAE, the cheerful intern, suddenly told not to speak; and Issa, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic backchannels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3. Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3 Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself, a loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one? It's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I Atlas is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. The quiet, enduring presence and final assimilation of 3I Atlas compels a final, deeper, existential reflection on the value of the transient observer, us, humanity. The object, which survived for billions of years, only revealed its purpose and its secrets during its brief, fleeting encounter with our species, the observers of a moment in cosmic time. Imagine the hyperdense core arriving in our solar system 4 billion years ago. Before life on Earth had even begun to form, it would have passed by silently, its magnetic pulse a whisper that went unheard by the primordial soup. It required the development of human scientific curiosity, the invention of radio astronomy, and the construction of the James Webb Space Telescope to even detect the subtle drift and decode the final magnetic pulse. The quiet, humbling realization is that the artifact's immense longevity was dependent on the emergence of a transient, sensitive observer to complete its mission. The object waited 7.5 billion years, not just to complete its trajectory, but to encounter a civilization capable of measuring its Magneto-orbital perturbation and recording its destruction. The mythic echo here is to the idea of the chosen witness, or the kairos moment, the belief that events unfold until the precise, opportune moment when the right observer is present. Our brief lifespan, our highly energized civilization, provided the necessary sensitivity to detect the magnetic whisper that a billion years of quiet, planetary evolution would have missed. The three anomalies, hyperdensity, conductivity, and the rhythmic pulse were, in a sense, a test for intelligent life. The hyperdensity required advanced physics to understand its origin. The conductivity demanded a mastery of electromagnetic principles, and the rhythmic pulse required sensitive, low-frequency detection technology. Our ability to explain them was our qualification as the designated recipient of the object's final scientific dividend. The human reflection is one of quiet gratitude for our own short, vibrant existence, Our transience is our strength. The very speed of our technological evolution allowed us to catch a piece of deep history before it vanished forever. We are not cursed by our short lifespan. We are uniquely equipped to capture the fleeting moments of cosmic history. Dr. Avi Loeb, summarizing the exchange, noted the ultimate cosmic arrangement. The universe sent us a time capsule, guaranteed to last forever, and we provided the ephemeral, high-speed scanner needed to read it. Longevity and transience completed the transaction. The dry humor of this reflection is that the universe often relies on a temporary, high-strung, curious species to complete its grand, slow-motion designs. Our short, noisy lives were, paradoxically, the essential ingredient for understanding the longest journey. The rhythmic 12.15-hour magnetic pulse is now the quiet memory of this exchange. It teaches us that to understand the vast, slow pace of the cosmos, we must value the brief, brilliant moment of our own observation. We are the transient observers, and that is our ultimate, profound value. We now move to the final, gentle moments of the narrative, preparing for the quiet closure of the story and the object's final, silent farewell. The saga of 3I Atlas is now complete, its hyperdense core assimilated into Jupiter's depths. The penultimate act is the final fade, the quiet, gentle disappearance of the object from our active scientific consciousness, leaving behind a lasting legacy of physical and philosophical change. This is the farewell of physics, as the object's unique influence is mathematically accounted for and merged with the background noise of the cosmos. Imagine the final orbital calculation now running in the background of every planetary model. The Magneto-orbital perturbation, the MOP, is no longer a paradox. It is a known variable. This process of integrating the anomaly into the law is the ultimate scientific farewell, a quiet nod of acknowledgement to the object's unique contribution. The memory of the 12.15-hour magnetic pulse is fading from the data streams, replaced by the chaotic, deep-field magnetic signature of Jupiter. But the knowledge that the pulse was there, and what it represented, superconductivity, persistent rhythm, 7 billion years of travel, remains indelible. The object has ceased to be a physical traveler and has become a constant in our equations. The mythic echo here is to the figure of the quiet teacher or the invisible guide, a presence that leads you to a new understanding and then silently vanishes. 3I Atlas was our guide to the physics of interstellar magnetic travel, and its disappearance marks the moment when the lesson is learned and the student must proceed on their own. The three anomalies, hyperdensity, conductivity, and the rhythmic pulse, are now the bedrock of the new IHDR classification. The object's unique properties have provided the new framework for understanding interstellar matter, ensuring that its influence will persist in every future textbook and research paper. The human reflection is one of quiet acceptance. The object is gone, but its data legacy is eternal. The quiet closure comes from the understanding that the universe is vast, and every piece of debris, no matter how small or dense, has a specific, understandable purpose in the grand mechanism. We witness the journey and the final purpose of a stellar refugee. Dr. Avi Loeb, in his closing remarks on the object, simply noted, "It didn't just teach us about space, it taught us about time. It taught us that the most successful projects are the ones that simply refuse to stop." The dry humor of this final fade is that the most influential discovery of the decade, the interstellar artifact that redefined planetary physics, is now nothing more than a few hundred lines of code in a massive computer model forever affecting the trajectory calculations of all future spacecraft. The quiet, gentle rhythm of the documentary now mirrors the final, silent acceptance of the object's fate. We have completed the journey of observation and reflection. The ultimate fate of the traveler is one of quiet, beautiful persistence, even in assimilation. We now prepare for the final, quiet moments of closure. The quiet journey of 3I Atlas is complete, its final resting place, the turbulent core of Jupiter. But the story does not end with its physical assimilation. It continues in the long memory of human science and the quiet return of this new knowledge to the vast cosmos. The artifact is gone, but the fundamental lessons it delivered will perpetually alter our view of the universe. Imagine the long memory as the scientific community's sustained effort to decode the spectroscopic data from the impact plume. For decades to come, researchers will be meticulously analyzing the lines of light, the signature of the ancient, hyperdense core, to extract every last piece of chemical and isotopic information. This slow, patient work is the ultimate tribute to the object's endurance. The information, having waited 7.5 billion years to be read, will not be rushed. The quiet return is the subsequent launch of new probes, designed with the lessons of 3I Atlas in mind. Future interstellar missions will likely incorporate the magnetic sail concept and carry instruments specifically designed to measure Magneto-orbital perturbation. Humanity's next great leap into the void will be fundamentally shaped by the physics of this single, dense, dark traveler. We are sending the lessons of the artifact back out into the cosmos. The mythic echo here is to the concept of the revenant, or the enduring spirit, the belief that something is gone, but its influence is permanent. The spirit of 3I Atlas lives on in the new mathematics of MOP and the redesign of our spacecraft. The three anomalies, hyperdensity, conductivity, and the rhythmic pulse, have been transformed into the three core principles of interstellar physics: durability, interaction, and persistence. These are the quiet guiding lights for our future exploration. The human reflection is one of quiet acceptance that the great mysteries of the cosmos are often revealed by the simplest, most enduring forms of matter. The journey of 3I Atlas has taught us that the universe is predictable, that matter is incredibly resilient, and that the greatest discoveries require the most profound patience. The dry humor in this quiet return is that the universe successfully used an ancient piece of metallic shrapnel to teach humanity a valuable, expensive lesson in magnetic physics, and now we are diligently following the homework instructions. The rhythmic, 12.15-hour magnetic pulse is now the quiet soundtrack to our future exploration. It is the metronome of our ambition, reminding us that success in the cosmos is measured not by speed, but by endurance. The long journey is over, but the quiet rhythm continues in the form of our scientific legacy. The final fade is complete, and the quiet memory is all that remains. Rest now, with the knowledge that the cosmos is a deep, quiet, and profoundly patient place. The history bends, but the physical laws never break. The quiet journey of the dense traveler, 3I Atlas, is over. Its core, older than our sun, now sleeps within the turbulent depths of Jupiter. We have witnessed a cosmic narrative spanning 7.5 billion years, a tale where hyperconductivity met magnetic destiny. Our ancestors survived soup that might kill you, and this object survived epochs that might destroy a world. We were looking for loud signals, but we found the subtle, rhythmic pulse of perfect endurance. We were looking for chaos, but we discovered the quiet, elegant certainty of magneto-orbital perturbation. The object is gone, but its legacy, the new science, the humbled perspective, the challenge to our ephemeral ambitions, remains permanent. The universe is a vast, profound place, and its secrets are revealed to the patient observer. Rest now, with the quiet knowledge that the most enduring things in the cosmos are the simplest: the laws of physics, the power of a perfect rotation, and the memory of a subtle, persistent rhythm. History bends, but never breaks. The ultimate journey is the quiet one.